Hello everybody. In today's lecture we'll be discussing active mode or dynamic mode in processing. So this is quite a pivotal point for us in our understanding of programming and in our learning of the processing language. So far we have been using static mode in processing, and what that means is we have been just writing code in one block. We have been just calling predefined functions, and there hasn't been any structure to our code whatsoever. When we write program in active mode, that is when we have a very specific structure to our code, and we have our setup and draw functions, and we'll discuss that in detail in this lecture. So the objectives of this lecture is to understand the program structure in processing and how we can have active mode. To become familiar with the setup and draw functions. Those are very important. And to understand variable scope. So now that we're moving towards active mode in processing, which is going to be quite important, and what we're going to be doing for the rest of the semester, we're going to see how variables actually would fit in all of this. So we're going to discuss this as well. First of all, we have the two functions. They're called setup and draw. So they're referred to as methods or functions. Basically, think of them as blocks. So we have been using predefined functions. Now, this is the first time that we are actually experimenting with functions. We are going to do a lot more with functions, but for the time being, I just need you to understand that we're going to have two blocks of code that are going to have their own little scope and their own and they're going to be separate from one another. So when you open up processing, as usual, you're going to have a setup function. It's going to look as such. So you're going to write void. Don't worry about what that means yet. We're going to talk about that in details in the weeks to come. The name of the function is setup, and the syntax is that you're supposed to have basically an empty brackets right up front. So if you don't have the brackets, you're going to get an error. Also, you're going to have curly brackets open and closed. So this is from here, from this curly bracket to the end. That's going to be the scope of setup. Anything you write within those braces is going to be the scope of your setup, and it's going to be part of setup. Anything outside of that is not part of setup. So processing has these two functions in pair. With setup comes draw. So again, void, draw, brackets, open and close braces. The scope of draw is from the top to the bottom. So this is quite interesting if you think about it. It's two blocks, and I do apologize for the fact that I keep saying, for the void or for some of the syntax, don't worry about it for the time being. Just use it, and we're going to get to what it means a little bit later. Okay. So, curly braces for both functions, and basically, just a really quick explanation that in C, C++, PHP, a lot of these programming languages, including processing, the blocks of code are specified using these braces. So when we have these two braces, that is going to be the block of code that is called, for example, setup or draw. So that's a little bit of explanation here I have for you. And these slides are all posted right beneath the videos, so you can print them, study them, and review them. The structure of setup and draw in a processing program is as such. So here's the flow chart. So you have setup. The computer looks at setup first. It'll execute the commands inside of setup. Then it will go to draw. The thing about draw is that draw keeps on repeating itself. So it's a convoluted concept to get, but it's not that bad. It's basically, draw is a function that keeps on repeating itself. So whatever you put inside of draw, whatever instructions you put inside of draw, it keeps on repeating itself. Let's see what I mean. So I have setup, I have draw. In my setup, I'm going to write a print statement. So I'm going to say println. I'm going to say this is in setup. And setup only runs once. So when I run this program, oh, it's taking a little bit this time. So this is in setup. That's what you get. Now, if I do the same thing, if I do a print statement in draw, and basically say this is in draw, and then we run this, let's see what happens. So this keeps on writing, by the way. So like this keeps this keeps on repeatedly typing. This is in draw, this is in draw, this is in draw, and it types it 1,000,000 times or 1,000,000,000 times. How many times that if I left it running, it would keep on repeating to execute this one line of code, which is println this is in draw. So it will keep on printing this to the screen. So that's really cool, right? If you want to do an animation or things like of that nature, as we're going to study them, this is basically what you will have. You would put it inside of draw, and draw will keep on repeating it for you. And setup only happens once. So like if I go on the very, very top here, so I'll take my cursor, go at the very top. It doesn't even have it because I let it run for so long, so you can't even see what setup printed out. So that's basically how it works in a nutshell. You have the instructions in setup that happen only once, and then whatever you put in draw, it keeps on occurring, it keeps on happening. So here is an example. If you have if you've gone through the tutorial on the processing website for the Zoog, the alien that you draw, this is an example of how you could have you could divide that in setup and draw. This is a little bit advanced, so come back to this slide after we are done talking and study it on your own. This slide, I wanted to just say that how is that possible? How is it possible for draw to keep on looping? And again, it's due to an invisible line of code. So we don't see everything that draw has to offer. So the makers of the processing language have made draw to keep on looping. So this slide is not for you guys to really let's say understand it, but it's basically for you to know what the reason is. So nothing in programming happens just because. This is something that that has been is a feature of the language, that draw keeps on looping. So apologize. So in setup, you typically put functions such as size, smooth, frame rate, background. For the most part, size and background are the most things that you would play around with. So all these functions, smooth, frame rate, these are all listed on their references on the processing website. And again, it's your job to go and look at any function that you might need. So this course isn't really about teaching individual functions. You guys are university students. You have been excellent students in high school, and that's why you came to university. So you are more than capable of figuring out individual functions and seeing what those functions will do. But typically, for example, size must go in the setup function. In fact, in processing 3, I think they're really enforcing that rule using the compiler. But in processing 2, they're still laid back. But the size goes here. So every time you start with processing, what you will do is you would set up size, and for example, we'll say 500, 500. And when we run this, and I'm going to take this line out. So notice that I didn't delete it, but instead I put comments before it. So this line is a comment now, which means computer doesn't look at it. It just skips right over it. This is called commenting something out. So I commented this line of code out instead of deleting it. A little bit of programming lingo for you. So when I run this, you see that the screen is 500 by 500 now. It's much bigger than the tiny screen that we had before. Or I could change the background. So there are many variations to the background function, but basically, if I put 100, let's put 200. So the background color is gray now. If I go ahead and I put 250, the background is white. If I go put something like 0, the background is black. So the background, I can talk more about the background, but basically there are many variations of the background function. One is to just give it one value. If you give it one value, it basically goes from 0, which is black, to 255, which is white, and any number between the two is going to be start approaching gray. So 150 is pretty much perfect gray, and that's how you set the background. There is another variation of the function background, and that is a function that takes 3 parameters. So 3 numbers, 3 inputs. In here, this works in the RGB system. R being red, G green, and B blue. And when you combine those 3 numbers, you're going to get different colors. So if I put, for example, if I put a 255 here under R, and then I put 0 and 0 for green and blue, and I go run, you see red. If I mix it up and I add some blue to this, so again, it's binary, it goes from 0 to 255, right? You get, let's say, 120 in here. I'll run this. You get that color. So you play around with the RGB, and it's actually pretty cool. So if you go to processing.org, and we go to references, backgrounds under setting. So you kind of see background. If you have 50, 51, it's still very dark. It's still black. If you get background with 3 parameters, you can mix it up. So if you haven't, if you don't know about the RGB coloring system, Google it. It's a lot of people know what it is, but it's basically where you would set a number for green, set a number for red, green, and blue, and it mixes those, and it'll give you a color. So that's something cool for you guys to play around with. All right, the next thing to talk about is variables. So how do we deal with variables now that we have a structure to our code? Now that we have a setup and we have a draw, how do we define variables, and how do we use them? All right, and I'm going to do another video on that. Thank you.